to summarize this, we try to approach the real value as accurate as it is necessary for this application. 3 general terms that are also related to technical measurements is the accuracy, the precision, and the resolution. When we see here how this can be combined, we see here in the red points a measurement, a single measurement from a sensor, and we all want to have it as we see it on the left-hand side. All measurements together near the true value. But in reality, it sometimes looks like this more. So where it is less precise and less accurate. And the reality, we are somewhere between these both points. So in technical measurement, we call this uncertainty, measurement uncertainty. This uncertainty is not an error. It's just something technical that you have to consider for your application, and not by defining an error. So if you look here in our IoT applications, if we have, let me say, a nice dashboard, the trend looks like this, but technically right, it has to look a little bit like this or like this. That means we have a tube between your real measurement value that describes the uncertainty that you have within your measurement. And now we want to see a little bit more in detail how this uncertainty is affected and what we can do and where this uncertainty occurs.
Thanks. We can separate the deviations into 3 categories. Number 1 is the sensor by itself. Number 2 is the application. And number 3 is processing the data. On the next slides, we will have a focus on the sensor and then the application side. This is a typical multi-room sensor, which already comes with 4 potential sources for deviations. So we can say the sensor element by itself, depending on the sensor element, we see different measuring results. That's pretty clear. Then the CO2 value, we see sensors in the market which measure the CO2 value. Others just calculate the CO2 value. The natural drift, each sensor has a natural drift. And the drift depends on the sensor element. But there are counteractions possible to work with that drift to ensure that the sensor value is always correct over lifetime. And the flow analysis describes the airflow inside the housing. Depending on that, we see clearly difference between the measuring results. So let's have a look at the application side.
When we're talking about applications, we have chosen 2 typical applications that we want to present to you. The first is the application that is in an air duct that nearly every building has in different kinds. And the first point we want to look is about response time. If you mount a duct sensor within a thermowell that is plugged inside a duct, and you use it without heat paste, that is a paste that improves the heat transition between the sensor element and the thermowell. And sometimes on the construction side, this is forgotten. So we see how the response time is decreased by this. And if your measurement is especially taking place on this point, then you have a deviation in the measurement value, which can be, let me say, hindered when having more awareness. And the picture below, I guess it speaks for itself. That's something that we oftentimes see on construction sites or within projects. And I guess it's quite sure that the sensor that's mounted within this duct would never give an accurate measurement value because of all the dust that's inside.
Let's have a look at a typical indoor application. Currently, we see a clear trend to multi-purpose sensors. A multi-purpose sensor comes with some advantages and also disadvantages. On the advantage side, we can say we have less cost, we have less installation and integration work. The disadvantage is that a sensor or the installation of a certain value is not the best place. Let's assume we have this sensor which comes with 5 values: temperature, humidity, motion, state, and brightness. And it's installed on a window frame, as we can see it here. So let's have a deeper look at the temperature value. When we combine the black line, which shows the target temperature, and the blue line, which is the measured temperature on the window frame, everybody would say this application runs appropriate on the best conditions. The red line indicates a sensor value from an external temperature sensor which is installed inside the room on the wall. And you can clearly see that the temperature inside the room is always 1+ above the measured temperature on the window frame. This is a result of an improper place of installation for the temperature value.
So when I'm talking about retrofit projects, we oftentimes have, let me say, new wall coverings. And in some projects, we saw that some wall coverings, like lime plaster, is emitting CO2 after the finishing process, even over months. So that's also a reason where, for example, the CO2 value in new projects or retrofit projects can, let me say, deviate a little bit from that what you expect. When we then talk about occupancy-based sensor applications, we try to figure out how a time-based occupancy profile looks like, starting in the morning and end in the evening. But then when we equip this with an occupancy sensor, we can see that the real occupancy is just 65% of the real occupancy. And we can, let me say, optimize our application a little bit with installing a proper sensor and get this proper measurement value out of a typical room. Then an additional point which we see in project is the air draft. It should be clear that a sensor that is directly mounted in front of an air handling unit have an improper temperature measurement, but every room, even without an air handling unit or a split unit, has its own radiation profile. Some walls, the warm air is rising, and on other walls, the cold air is falling. So, and depending on different walls, on different conditions in the room, we have many projects seen in the field where air draft in a room was a real reason for temperature measurement deviation. Another point, a slowed response time. When we're talking about offices, sometimes we have big open spaces and you have the heat source perhaps on the left-hand side or very far in the back, and just one temperature sensor is mounted to gather the temperature value out of this room. So and if there is a big distance between both of them, the response time between these two could also lead to a kind of deviation that's later seen in the application. So and now we want to see how we can combine all these points that we have seen into one application and what this means later on for this application.
Yeah, typical heating application, I guess we are all at the same page that heating has a lot of potential for savings. And the story is very short. When the smarter your application is, the higher is the potential cost savings for your installation. And and as we discussed before, every device brings the sources for deviation. And that's the point here Marco would like to explain, which could be the impact of all this deviation in that entire application.
Exactly. As Mario said, we can, let me say, sum up the deviation that comes by the sensor itself, but also by the application, what we have seen before. And this leads to that we can, let me say, to make the calculation a little bit easier, we decided to put an average deviation about all these points that we have seen before. And what we try to figure out here is the additional saving that you can generate just with having more awareness of the accuracy of your application. It means this 380 euros that you could save with this application is not, let me say, the general savings that you could gain with installing an IoT application, just the additional saving that you could put on top of an already existing one. And even if you scale this more to a bigger project where we have a bigger office, you see that even this number of savings, of annual savings, increase step by step. And we hope that this figure could make clear how our initial question could be answered. Yeah.
Thanks. As you can see, there are a lot of points to consider to make your foundation as solid as possible to ensure that you have sensor values which are appropriate for your application. And to answer the initial question, yes, accuracy matters. And without appropriate and accurate data points, you cannot use the entire potential of your IoT application. So would be happy to see some of you at our booth at A13 to discuss this in more detail. And yeah, in case of having any additional question, we are here for some minutes on stage. And yeah, looking forward to see you later.
Also from my side, many thanks for your attention. And if you have any points, also application side you want to discuss, please feel free to reach out. We are here during these 2 days. Many thanks.
Thanks.
Mm-hmm.